The broadcast is now starting. All attendees are in listen-only mode.
Hi, everybody. Sorry we're a little bit late starting. Thanks for joining us. I have Brent Ness from Redline Communications and Pat Redmond from Alliance Corporation on the line. And Pat's going to do a brief introduction, and then it's over to Brent. Go ahead, Pat.
Thanks, Lisa, and thank everybody. On behalf of Alliance Corporation and Redline, I'd like to thank everybody for joining today for this critical infrastructure web session that's going to be done by Brent Ness. Now, Redline's done a really good job of product development and product positioning and capturing a large portion of the oil and gas market to the point that Redline is considered a de facto standard in some cases in that market. But Redline is also a really good fit for a lot of other markets, like mining for municipal networks, and we're even starting to have an impact with enterprise ISPs as well. With the price of oil the way it is today, you guys, and a lot of our integrator partners out here in Western Canada and across Canada are entirely focused on that oil and gas market, they thought it would be a great time and a great opportunity to share some of the new things that Redline has done with Release 3 that's almost on the way out now, and some of the other markets where Redline is also having some success, and they're a really good fit in some of the muni and mining and some of the new markets that we have not approached yet. So with that, I'm going to turn it over to Brent Ness.
Thanks, Pat, and welcome everybody on this sunny Tuesday. I'm not sure where everyone is, but it's a little gloomy here in Calgary. But thanks for taking the time to go through this. I just wanted to, I guess, kick it off and say that, you know, Redline is very appreciative of your business, and we welcome working with all of you in multiple capacities in order to ensure that, you know, we have successes across the board. And, you know, we really are, I guess, you know, helping enable you to deliver services to your end customers, and really your customers are our customers. So we welcome working with you on many fronts. Just a quick agenda here. Let me just click the button here and we'll go through it. I just wanted to say we're going to probably spend about half an hour. I don't want to make this long and lengthy. Just want to go through a quick update of Redline 3.0. This is a new version that's actually going to be released shortly. We're looking at probably over the next week or two. It'll be generally available for all of the new radios when they're delivered to the end customers on version 4. Just want to talk about some of the challenges, some of the things we're seeing around you know, design challenges when it comes to you know, building your wireless infrastructure, some of the features that you need to consider as well, and I'm sure most of you folks are aware of this, but I'm kind of doing this in two stages. One is I want to talk a little bit about the technical side of the capabilities of the radios themselves, and the other side I want to talk to is really the approach to the end customers and how the sales folks can go out and talk to the customers about the capabilities that we have and some of the strengths, some of the differentiators that we have within the product suite itself. And doing that, I want to go through some case studies that really talk about, you know, some of the biggest challenges, and really around range, capacity, reliability, you know, spectrum, line of sight, those type of things. But just as I guess as a lead into this, and just to talk about it, for those of you that are aware, Redline is a Canadian company. We're based out of Markham, Ontario. We've been around since about 1999, so we're actually a very well-established Canadian success story. Publicly traded on the Toronto Stock Exchange. You know, very focused on our customers. You know, we've only got about 140 employees, so we've really got the ability to be very customer-centric with our designs. You know, if an opportunity arises where a customer says, "Hey, I would like to have this," and you don't have it, talk to us. Let's look at that and see what the options are. Maybe it's something that we can look at. Our claim to fame is we are a point-to-point, multi-point, and nomadic provider. We don't do any Wi-Fi. We're not in that space. We don't do any mesh technologies. It's truly a clear focus within that marketplace. We've got a global footprint within the market, not only in the oil and gas side, where we've seen some great successes over the years, but you know, as we all know, the oil and gas market's taken a bit of a hit here, and I think people are kind of wondering where the projects are going to go and how long they're going to be delayed or canceled, that sort of thing. But from a global installation perspective, Redline really does have a solid footprint. We've got, you know, products that operate, excuse me, from the from the 150 megahertz range right up to 6 gigahertz. And this includes installations in the North Slope of Alaska to the, the rugged, hot, dry desert conditions in jungles and offshore climates and so on. So our virtual fiber technology really is the claim that we have when it comes to extending the capabilities out into the field. Our new software version, version 3, has been in development and actually in production in the field testing for a better part of a year. This is quite a significant change in the Redline capabilities that we have, and it's really going to position us to be a leader stronger than we are today within the marketplace. This is going to be rolled out in our R4 platform, so for those of you who've got products deployed, this software feature is only going to be available on R4 going forward, which is a product that we've been shipping out in the past, I would say probably the past 12 to 14, 16 months, so that's something to consider there. So some of the things we've added, we have introduced a lot more smaller channel sizes. Where does this come into play is really in the design. So when you're designing a wireless network, having smaller channel sizes out there really allows you to maximize the spectrum out there. And so this is more of a design issue, but it also works well on the sales side as well, is that we can put more channels, more users in a smaller slot in a multi-point environment, as an example. So it really does allow us to optimize the spectrum. It also allows you to build over a network. So if you've got an existing network in place today and they've maximized all of their bandwidth on that, as long as we can steal a little bit out of there, we can start building an overlay network and migrate to that. The other part was that we've really increased the optimization of the protocol as well. We've done this by increasing from 5 to 9 bits per hertz. So this is making extreme efficiency of the protocol that we are using today. The other thing is we also have increased our modulations. What this really results in is that 256 QAM is actually going to allow you to get speeds on the radios themselves up to about 186. Pure marketing side, I would say conservatively 150 meg on that using 20 meg channels. So again, a very good improvement. We've also added SpaceTime block coding. This really is a signal enhancement for that, so you can actually get some increase in your signal. And one big part that I know is going to be interested to a lot of the ISPs, the service providers, is the support for fixed frame. And this is something that we announced for some time, and now we have it in version 3.0. So this is going to help enable some of the ISPs and so on to build stronger densities in their network. Excuse me. They also have a faster registration time on the radios themselves. So if you've got multiple radios connecting into a single base station, as an example, we're really cutting down the re-registration of that. Some new security software, cryptography, is helped to generate the pair between the radios themselves. So this means basically a faster connection time between the radios. Excuse me. So I want to talk a little bit about some of the wireless challenges that we're seeing out there, and this applies to pretty much every industry, including transportation, public safety, video surveillance, whatever it may be. One of the big benefits I think you'll find with the Redline solutions is that we're very efficient in our spectrum use. We are very efficient when it comes to the optimization of everything from the power to the basically the radio transmission, receive, and so on. But one of the things I see all the time when I'm out talking to end customers is how some companies or designers are quick to try to increase the antenna size or increase the power output in order to overcome some of the challenges that we're seeing with some of these issues. Something like reflections, where what we do is we solve that problem with dual radio transmission and receivers. And it allows you to really, I guess, increase the diversity on the radios themselves, maximal benefits for the end users. Scatter is another one, and how we're actually taking care of that is the use of another diversity technology called maximal radio receiver technology. And this is something that is part of the design of the network, and it really is, I guess, it's key more for users in the design. So it's more features, more functions. Inversion as well as ducting. So these are some of the key things that you're going to run into problems with when it comes to the design of the networks themselves. And keep in mind that we do a very efficient job of how to take care of that. MIMO is a technology used from the radios themselves. Stands for multiple in, multiple out. This is really where you combine 2 radios and 2 receivers, and it gives you some significant benefits. in MIMO-A, what it does is it actually sends duplicate copies of the same transmission to two transmitters, through two transmitters to the other end. And what the radios really do is they compare the signal when it is received at the other end, and they basically, for simplicity, it picks the best signal of that. And where this comes into benefit is it really increases the quality of the signal in non-line of sight conditions, or where you've got some conditions that are causing some problems. The other thing to mention on this is Wi-Fi is not supported in MIMO-A. They don't support it in their build. So any of the Wi-Fi technology products out there, which are 802.11, do not support the MIMO-A. MIMO-B, on the other hand, this allows you to basically increase the throughput. You can, in essence, double the speed of your transmissions. And this is in an optimal conditions. If you've got good line of sight, what happens with MIMO-B is it basically transmits the same, double the data speed, if you want to call it, over the same radio channel. So it's very efficient in that space. Redline uses both MIMO-A and MIMO-B for all of our deployments in the RDL 3000 platform. So it does really help us to stand out in the industry a bit. MRC coding, this is really allows the receiver to choose the best signal-noise ratio between them. Redline deploys what's called MRC, maximum radio receive combining. And this is really what happens is it does a lot of comparison in the signal ratio, and it allows them to maximize the efficient use of it. It's really what it comes down to. You get some additional gains on the link budget from that, but it's a very efficient design for that, if you want to say. The other part is we've introduced is something called SpaceTime block coding. Really what this does is, again, these are all techniques to improve the quality of the signal, so it really transmits multiple copies of the same data across an antenna, and improves the reliability of the data transfer that's being used out there. So as data comes in, they're put into separate blocks, redundancy is created across there, they're rearranged at the other end, and it improves your signal performance across the end of the circuit. The other thing that's very interesting is we've introduced a dual frequency redundancy. What this allows you to do is on the right-hand side, you can see that data is coming into a switch. If the switch has what's called parallel redundancy protocol enabled, the data is in essence duplicated. You can send this across two different radios, two different frequencies, and what it does at the other end is it basically picks the best signal between that, puts the packets back in, and transmit that. So these are very efficient uses of I guess the radio spectrum. We've got some additional redundancy in there now. We've got some additional capacity. We've got more channel sizes. We've got more security. So these are great enhancements that we've done to the product itself. So now I just want to talk about a little bit about some of the challenges that we're seeing with some of our customers, and the way that we're overcoming some of those challenges. These are kind of the four biggest things that we're running into on a regular basis. And primarily in the transportation, security, public safety, railroads is another area we're seeing some of these pop up as well. So range and capacity is obviously number one. The second, reliability, absolute reliability is a key factor. Line of sight to remotes, can you see what's going on out there? Can you see end-to-end on the circuit? And then the available spectrum that's available within each of those. So I just want to go through those a little bit. First part I just want to talk about when it comes to range and capacity is that efficient use of the radio spectrum that's out there is really contingent upon what you can see and the coverage that you have. And a lot of the deployments that are placed in the industry today are reliant on towers. Towers are the easiest way, obviously, to see for line of sight, and it's also the number one cost in the capital expenditure when you're building a network that's out there. The cost of the towers themselves really does come down to building the foundation. You've got to have power, grounding, lighting, all that other stuff, and the cost can vary. In large tower environments, can be up to almost $1 million to build a tower. So the minimum amount of towers that you can actually have to deploy in a network is the key, number one thing in your return on investment. So having a very efficient radio design and a very efficient way to deploy those with extended reach and so on is a significant benefit to you as an end user or to the customer when you are looking at deploying the network. The other part is reliability. And this is a key factor when we look at the long-term ROI benefits behind the deployments of the technologies. So what happens when a radio fails in year 2? There might be a fairly inexpensive deployment coming down when you're rolling out this product. One product might be significantly more than the other, whatever it is. But what happens when you need to fix it? Who takes care of that? How much is going to cost for that year 2 build, year 3 maintenance contract, and so on? So a lot of the, I guess, if you call them ISPs as an example, the tendency is to try to look at a lower cost product out there, and this is where you can maximize your return on investment in order to generate revenue and so on. But at the same time, there are failures that occur within that environment, and I think that's one of the things you'll find with the Redline solution is that our failure rate today is less than 0.3 of a percentage, and this has been this way since about 2005. So we've got a significant, I guess, advantage when it comes to the deployment and the ongoing ROI associated with the products themselves. The other problem and the other challenge, I guess you could say, is when it comes to line of sight. With the frequencies themselves, and we'll get to this in a couple of slides, obviously the lower frequencies have better transmission capabilities than the higher frequencies. What I mean by that is line of sight. If you don't get line of sight within those frequencies, you have to go to a lower frequency spectrum within that. Some of the smart technologies that we use, like MIMO A and MIMO B, some of our diversity techniques, and so on, really provides a high availability, a high reliability deployment. So you don't necessarily need to have the radio sitting high on a pole in the middle of nowhere. And what happens when that breaks? And somebody has to replace that and go out and fix it. So these are also things to consider as well. The other thing to look at is available spectrum. This is not so significant today in some of the rural areas that we're seeing here in Canada, but it's going to become one. A lot of users are deploying frequencies out there and not considering channel size and not considering the future build. We'll put in 40 meg channel sizes and we'll blast the heck out of this thing and give you 200 meg of traffic across the street. But down the road, there's going to be some efficiencies. It's going to be required, I believe, that efficiencies in spectrum management are going to become mandatory, whereas users are not going to be able to do that. So the usable spectrum, really, when it comes to, I guess you could say, the traditional side of the world is everything on the left-hand side, which is kind of the radio and TV, through to the cellular technologies. We get up into the Wi-Fi and LTE, and then we get into the unlicensed kind of that 5.2 to 5.8. And then on the right-hand side is really what we consider the microwave or licensed spectrums. The higher wavelengths really are better situated for line of sights, and that's the key with those. So spectrum is going to become a commodity that is going to have to be used very efficient, and that's where, with our smaller channel sizes, I think we're going to see a significant improvement in the way that deployments can take place and the management of those as well. So just want to go through a few case studies of where we've actually seen some successes. And again, you'll see how we've kind of broken these into range and capacity, reliability, and so on. And this is really, I guess, the success of our technology and how it's deployed in the field. So just want to talk, first one is Utah Department of Transportation. This is quite a large deployment, and some of the challenges that they had was the coverage area specifically. A large geographical area across a very densely populated terrain, as an example. And how this was actually overcome is, again, back to maximizing the efficiency on the radios, is that we were able to do this with a 14 radio base station network. In comparison, I think we were looking at 26 or 27 radios using another technology. So this significantly reduces the footprint and the deployment and obviously the cost to the end user. So today basically they've got 150 critical areas and monitor those with the video surveillance as well. And how we did that, obviously the technology on the radios, the transmission capabilities using OFDM, so we get better power to the radios themselves. We've got a very tight, clean spectrum mask. That is a highlight that Redline is very proud of. Our spectral mask efficiencies are very clean, and we don't interfere with associated channels next to us. And then the use of MIMO A and MIMO B, so we can increase the range and capacity using both the uplink and the downlink as well. So very good success story with these folks. They're extremely happy. They're deploying more and more radios today as they expand the city. But again, a great example of the range and capacity. We look at reliability. We've got some deployments of some of the harshest conditions you could ever imagine, from Alaska to Australia and Africa and so on. This one with the Nevada DOT, they were looking at the issue around, they were getting extreme winds along the highways, and they've got extreme conditions too, like very cold environments and so on. And what our radios allowed to do is to have because our radios are small, they're only about 8 inches square, 8.5 is what it is. They've got a very low wind load. So again, they can handle the temperatures, and also they're built for rugged conditions, so the corrosion and so on. So now they've got these deployed across the state. So basically the whole I-80 is covered with that. Again, reliability side of things, if we look at our MTBF, or our mean time between failures, it's actually higher than this now. It's actually reaching 28 years. So we've got a very solid, successful track record of having a reliable radio that's out there. We build all the products with the best components. I was looking at some of the competitors the other day as far as products go, and we were seeing that the designs inside some of them haven't changed for 10 years. And so we've got a very solid product base. Use high quality products. Some of the products have higher ratings than others, but again, they're rated for the harsh conditions we have. So, what does this give you? This gives you the ability to be rest assured that your products can be deployed, and they're not going to have any issues down the road when it comes to the reliability of the product itself. Non-line of sight is a big challenge, as you know. Massachusetts DOT was having significant problems, and Massachusetts is a very hilly, woolly, tree terrain area. And so, again, one of the key things that we had with that was our smart antenna technology. So the antennas having either an integrated antenna or using external antennas, we can overcome some of these challenges when it comes to non-line of sight. So in their case, they had 28 bridges that they wanted to provide video surveillance first, and also for first responders, and so on. And so they overcame that challenge really with looking at it from the technology side of things inside the radio itself. So not only does we have the extreme conditions, we've got the long frequencies, but now some of the diversities inside the radio itself, like I talked about earlier, around the space-time block coding and the MRC. So this gives you, again, a reassurance that the technology used in the radio itself for those really crazy conditions that are out there is going to be reliable, it's going to be effective, and it can be used just about anywhere. So for them, the end result was that they had a long non-line-of-sight coverage area. We managed to overcome that, and they've got a very stable and very secure system today. And then the frequencies. We have, as I mentioned in the frequencies before, Redline supports everything basically from 100 megahertz up to 6 gigahertz on our RDL 3000 platform. What the benefit happened with the New Jersey Turnpike is that there was a significant saturation of frequencies that are out there today. And because of our small channel sizes that we have, as well as our very tight spectral efficiency, we managed to deploy a very efficient solution for the New Jersey Turnpike, and take advantage of proper management of those spectrum masks and circuits. And so it really was a very quite an efficient deployment. Because of the capabilities, again, the software-defined component within our radios, we can actually change the radios on the fly. So if one frequency is busy on one channel, we've got the ability to move it to another one. So these are things that customers want to hear, they want to understand, and they really do appreciate the fact that we've got these capabilities within the radios themselves. So again, the any frequency support side of things, most of the partners we have are certified and trained on that. Obviously, our customer support center can also help in that as well. But efficiency within the radios and having that I guess, wide range of frequencies, makes us stand out from the crowd. And the other part across that is really, we're an open standards product. That's really where we are. We've got really IP technologies. So, these are well deployed for the Port of San Diego, as an example, where they had a very complex network environment. They were looking for something open. They wanted some advanced, I guess you could say, tracking and tagging inside of their network itself. And they had basically 3 different network designs that were out there. So they wanted one to support voice, one for data, and one for video. And so with our open technology and some of our software-defined features, we had that ability to really support them. So this was an example where the open standards, the IP standards, and the layer 2 functionality we have really overcame the issue. And a standards-based PoE injector as well. So really transparent from end to end. So that really is about all I wanted to go through. I'm glad to have some discussions with anybody about the deployments that we have and where things are at. But I think just to summarize, New 3.0 is a very efficient deployment for us. We've seen some great successes in that with the something happened there. Some great successes with the testing that we have with the customers and the deployments. It's going to be available at the end of this month. I think for the users that are going to put 3.0 on the new platforms, I think they'll find that not only the throughput but the efficiency of the bandwidth is going to improve significantly. And so, just to kind of summarize, I think we've got some of the best products that are out there in the market today when it comes to industrial broadband wireless. And I welcome having a discussion with anyone really about the capabilities that Redline has and where we go. So I think that's about it for me. If anybody has any questions, you want to fire them off to me, or you've got my email there, my phone number. Feel free to reach out to me at any time, and be glad to help you out. As well as our partners at Alliance, Pat Redmond and Cody are also available at any time to help you guys out. We keep in touch on a daily basis on everything that's there, and look forward to further business and further opportunities. So if you have any questions, you can type away.
Thanks, Brent. I don't see any questions, so I'm going to assume everyone knows it all. So, and of course, I think they know you pretty well, so they know how to reach you if they do have any questions.
Yes, and I welcome that. Redline as a company is expanding our footprint. We're seeing some great successes. Even though there is a downturn in the oil and gas industry right now, we're still seeing successes in oil and gas. I think that's a true testament to the stability of our company, stability of our product, our future deployments. Municipalities is an area where we're seeing some good growth. Transportation, working with the railroads right now, and also the federal government. But everything takes time with the federal government. So, yeah, we're seeing some great successes, and I welcome any feedback or any comments on our product and how we can help our customers, our end customers, deploy their solutions in an efficient manner. So, looking forward to it. And thanks for putting this together, Lisa. I think these type of things are great to get the word out for Redline, and we want to make sure that our partners are kept up to date on the latest deployments that we have, the technology, some of our successes, and those will help them in turn win as well. So, thanks for that.
Thank you, Brent. And to everybody out there who's listening, if you do have any suggestions for webinars, I really appreciate them. I generally keep pretty busy with them, but I'd like to know what you'd like to hear about, so just send me an email. Pat, do you have anything to say before we shut her down?
Just a big thank you to everybody that joined, and as Brent mentioned, don't hesitate to call us, either Brent or Alliance, Cody, myself, because we're always available to help out. Whether it's providing a little bit of technical support or a little bit of guidance on the solution, and just to get things kicked off. If you need us to go in to visit one of your end customers on a new opportunity, we're certainly happy to do that.
Okay, great. Okay. Thanks, everybody. We'll talk to you again soon.